Namaskar. Now, last time we have observed and we have discussed three different number systems. Actually, four, but we are aware about the decimal number system and we could not identify that it is a special number system because we are well familiar with the decimal number system. It is a common practice for us to count the numbers in decimal number system, that is beginning from 0, 1, 2, 3, 10, 11, 12, 99, 100, 101, 102, 103, then 400, 401, 900, 998, 999 and then 1000. We are well aware about this system. But along with this system, we had observed the binary number system. Binary number system is the system in which the base of the number system is 2. There are 2 bits, these are called as bits 0 and 1, and with help of only these 2 bits basic numbers we can develop the number from 0000, it is 4-bit number, to 1111. The corresponding decimal equivalent is 0 to 15. One more number system which we have discussed is the octal number system, whose base is 8 and the 8 different symbols are the numbers from 0 to 7, and the progression of the number in octal number system, it is 4-digit number, will vary from 0000 to the final number is obviously it will be 7777. Here I have not mentioned, but if I continue the counting, then it will be 7777. Now what is the decimal equivalent of this and how to calculate, we will have to discuss. Now in case of binary number system, it is bit simple. Therefore we can say that 1111 in binary is equivalent to 15 in decimal. But how to convert the number from binary to decimal or vice versa, that we will have to discuss today. The fourth number system, that means the third new number system which we have discussed, is the hexadecimal number system, in which base is 16 and therefore for 16 different symbols we have used 0 to 9 numbers, these are 10 numbers, and then A to F letters. The decimal equivalent of A is 10, then B is 11, 12, 13, 14 and 15. Therefore, in all from 0 to 15. The progression of number in hexadecimal number system, it is 3-digit number is 000, and if I continue, then finally the number will be FFF. This is in hexadecimal number system. What is the corresponding decimal number, we will have to discuss today. For few simple numbers, at the end of last session we have discussed, it is 011 in hexadecimal number is equivalent to 17 in decimal. For 11 in decimal itself, because there is no practice to write is for decimal, because we were not aware about the other number system, and therefore it was obvious. That means if I write any number, say for example 54, definitely it is in decimal number system. But now it is possible that this number may belongs to the decimal number system, this number may belongs to the octal number system, or this number may belong to hexadecimal number system. Remember that this number is not possible in binary number system. This is wrong. The reason is very simple. The binary number should consist of 0 and 1 only. But now how we can think about the transformation, how this is converted from decimal number system to octal, octal to hexa, hexa to decimal, binary to hexa, etc. And for that we will have to discuss today. Okay. Now basically when I think about a number in any number system, how we can find that particular number in a particular number system. Though we are aware about the decimal number system, we will discuss in some other way, different way. Suppose there is 5496 in decimal number system. Actually this number is something like this. It is 5000 plus 400 plus 90 plus 6. Because we are familiar with a term, it is the place value. Here if you observe the unit place, then the place value is 1. If I observe the 10th place, then the place value is 10. For the 100 place, the place value is 100, and for this 5, that is 1000 place, the place value is 1000. Now in terms of base, if I will have to write those place values, then here I can write for the unit, that is the 6, the base value is 10 raised to 0. For this it is 10 raised to 1. For this it is 10 raised to 2. And for this it is 10 raised to 3. And therefore if I will have to write the number 5496 in decimal number system, I can write this number as 5 into 10 raised to 3 plus 4 into 10 raised to 2 plus 9 into 10 raised to 1 plus 6 into 10 raised to 0. Correct. And we are aware about such type of expansion of a number. At school level, sometimes we have done this exercise. What is the place value for 4? It is 100. And therefore, if the 4 is at 100th place, the contribution of 4 is of 400. If the 9 is at 10th place, then its contribution is of 90. But suppose the same 9 in other number is at 9, suppose the number is 9432, then this 9 has a contribution of 9000. See, fortunately I have kept the 4 at 100th place, but suppose if I write here it is 5, then here we will realize that it is 9000 plus 400 plus 30 and plus 5. Therefore, this 5 has a contribution of 5000 because it is at 1000 place, whereas this 5 has a contribution of 5 only because it is at unit place. Correct? And any number in decimal number system can be written something like this. And therefore, I can say that suppose I will have to convert the number from decimal number system to the number in decimal number system, then the conversion is something like this, and I can say that it is 5496 in decimal number system. Now you may say that this is of no use, because why there is need of conversion of a number from decimal number system into decimal number system? The interesting thing is that here, while considering 10 raised to 3, we had considered that it is 1000, and for that we have used our knowledge of power, knowledge of taking product in decimal number system, and therefore we can say that this number is in decimal number system, whereas this number is written in decimal number system. Now I will give you very simple example of conversion of binary number into decimal number, and then you will realize that though it seems to be meaningless, the meaning is important. How to convert a number from any base, now this is any base, to the decimal number system. Okay. Now in the parallel mode we will think about the conversion of a number from binary number system to decimal number system. That means suppose we have a number 1011. Now I am considering only 4-bit number because it is simple to compare with our previous situation. That means suppose here if I continue, it is 1000, it is 8, then 1001, it is 9, then it is 1010, then it is 10, it is 1011, then it is 11. Therefore we are aware about this type of sequential calculation, and for this 1011 we will check whether our method will give you the same result, that it is 11 in decimal number system, so that we will be confident about this method. For that, what we will have to consider, or here it is 2, or sometimes we may write it is B2. Okay, somewhere I have mentioned whether we can write it is, yes, it is 2, or we can write it is B also. Okay. Now what is the situation? What is the place value here? In this format I can write, as the base of this number system is 2, the place value of first place, least significant position, that we call. The least significant position has a place value of base raised to 0. The next significant position has the value of base raised to 1. Next significant position has the place value of base raised to 2. next significant position has the place value of base raised to 3. Therefore, the lowest or the least significant position has a base value of base or has a place value of base raised to 0. The first position, that is next actually, it is base raised to 1, then base raised to 2, base raised to 3. Therefore, what is the place value of this? Or I can convert, and therefore this number in decimal number system. Now, when we think about 2 raised to 0, this we are calculating with reference to the decimal number system, and therefore it is 1. When I think about 2 raised to 1, it is 2. When I think about 2 raised to 2, we are using the decimal number system, and hence we are converting the binary number into decimal number system. 2 raised to 2 is 4 and 2 raised to 3 is 8. And it is obvious because we are aware about the decimal number system, and hence for any base, for example, if the base is 8 in octal number system, we can think about 8 raised to 0 in decimal number system. Now in binary number system or in octal number system or in hexadecimal number system, the meaning of 8 raised to 2 may be different, because at that time 8 is to be considered in hexadecimal number system, but that will be complicated. Right now we will keep this aside, and while taking the power, where multiplying any number, where taking addition, we will adopt the decimal number system, because we will have to convert every number into decimal number system. And hence, in the similar manner, how can I write? This 1 is there, and therefore I will write it is 1 into 2 raised to 3. See, I am using same technique. Here it is 5 into 10 raised to 3. Here it is 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. Here you will realize that this 2 raised to 3 is from this place, this 2 raised to 1 is 2 from this 2 raised to 1 is from this 2 raised to 0 is from this, it is 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. Whereas this one is the most significant position, most significant bit. This is the next significant lower significant bit. This is the next lower significant bit, and this is the lower significant bit. Okay. Now if I continue, then I can write this is equal to 1 into 8 plus 0 into 4 plus 1 into 2 plus 1 into 1, and that is nothing but 8 plus 0 plus 2 plus 1, and you will observe that it is 11 in decimal number system. Now why it is in decimal number system? Just I have told you that the product, the addition or the power we are calculating with our previous knowledge, and our previous knowledge is for the decimal number system, and therefore I can write it is 1011 in binary number system is equal to 11 in decimal number system. Now verification is with us. Here we have observed that if I count from 00000001 by using our previous knowledge, that means if we will have to increment the number by 1, try to increment the least significant bit by 1. If it is not possible, then reset it to 0 and increment the previous significant bit or next significant bit by 1 and continue. Therefore it is 0000, 0001, 0010, 0011, so on. The corresponding counting is 0, 1, 2, 3 and so on, and finally we have reached that it is 1011, which is equivalent to 11 in decimal number system. Now here, using the method of conversion of binary number into decimal number system, we have found that 11 in decimal number system. Therefore it seems to be okay. But shall I continue this for any number? Obviously answer is yes, because this is the technique. Whether it is possible to check it, that may be homework for you, because you will have to write so many numbers. But I will give you one more number. Suppose it is 101101, and this is in binary number system, then what is its decimal equivalent? Therefore find the decimal equivalent of 101101 in binary. This may be the problem. Now we will continue. I can write it is 101101 in binary, but now it seems to be very simple. If I write it is 2 raised to 0, it will be 1. This is 2 raised to 1 it will be 2, here it is 2 raised to obviously 0 1 2, it is 2 raised to 2 means it is 4, it is 2 raised to 3 means it is 8, this is 2 raised to 4 means it is 16, this is 2 raised to 5, then it is 32. Okay, and hence I can write, actually I will have to write it is 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 1 into 2 raised to 3 plus etc. But instead of that, directly I can count this, therefore I can write it is 1 into 32 plus 0 into 16 plus 1 into 8 plus 1 into 4 plus 0 into 2 plus 1 into 1, and that is nothing but 32 plus 8 plus 4 plus 1, and I can think about it is 49, correct? Therefore I can write this is 101101 in binary is equivalent to 49 in decimal. Now if you will have to check, then what you will have to do? You will have to develop, or you will have to continue the counting in binary number system, and then you will reach 101101 at 15th count, beginning from the 0, it will be the 15th count, and therefore we can confirm that this is equivalent to 49 in decimal number system. Okay, therefore this can be treated as a technique to convert any number from any number system to decimal number system. This is important. Now can we use the same technique for conversion of octal number into decimal number system? Obviously the answer will be yes. Only we will have to take care that in case of the octal number system, base of the number system is 8, and therefore we will have to find the place value for that particular digit with help of base raised to the position. Therefore we shall find the, suppose the octal number is 256, this is in octal number system, then find its decimal equivalent. Therefore our problem is that find the decimal equivalent of 256 in octal number system. First of all, we will check whether the 256 is real octal number or is there a mistake. Any number in octal number system should vary from 0 to 7. 8 is not included, 9 is not included, A, B, C, D, E, F are not included in that number system, and therefore 2, 5, 6 belongs to the octal number system, and hence the number may be in octal number system. Now why I am calling maybe? Because it may be the number in hexadecimal or decimal number system too. Definitely it will not be number in binary number system. Okay, fine. We will continue. What is the place value for unit place in octal number system? As it is octal number system, it is 8 raised to 0. For the next significant position, the place value will be 8 raised to 1. And for the next significant position, the place value will be 8 raised to 2. 8 raised to 0 is equal to 1, 8 raised to 1 is 8, and this is 64, 64. And therefore if I will have to write the number 256 in octal number system, then as I am using the decimal number system for calculation, you have observed that 8 raised to 0 is 1, 8 raised to 1 is 8, and 8 raised to 2 is 64, 64 असं मी म्हणालो. Therefore the place value I have calculated in decimal number system, and therefore I am converting the octal number into decimal number. Okay, fine. How can I write? Therefore it is 2 into 8 raised to 2 means it is 64, plus 5 into 8 raised to 1 means it is 8, plus 6 into 8 raised to 0, that is equal to 1, and therefore this number will be it is 128 plus 40 plus 6, and that is equal to 8 plus 6, it is 14. Therefore I will write it is 4 carries 1, it is 5, 6, 7, and it is 174 in decimal number system. You can write it is 256 in octal is equivalent to 174 in decimal number system. Correct? Therefore it is very simple. You may think about, I will give you the homework at the end to convert the binary number, octal number and hexadecimal number into the corresponding number systems. Now we shall think about the hexadecimal number system. Let B1A is the number in hexadecimal number system, and we are interested in the decimal equivalent of B1A in hexadecimal number system. Now as we are using hexadecimal number system to represent the number B1A, we will have to calculate the place values using base to be 16 but we are calculating in decimal number system, and hence I will write it is 16 raised to 0. The place value for the next significant position is 16 raised to 1, and the place value for the next significant position is 16 raised to 2. Okay, and if I will have to write the number, it is B1A in hexadecimal number system, 2 decimal number system. Here the decimal equivalent for B is 11, and therefore I will write it is 11 into 16 raised to 2 plus 1 into 16 raised to 1 plus A means it is 10 into 16 raised to 0, correct? Now we will have to calculate this. 16 6 7 9 16 16 आणि 9, it will be 25, therefore it is 256 plus 1 into 16 plus 10 into 1, correct? That is equal to, we will have to calculate this. Again I will calculate and then add these three numbers. 11 66 चालेल 6 11 55 आणि 6 61 1 चालेल 6 11 22 23 24 25 26 27 28 28. Now you will have to be cautious about this. You will have to calculate if required, and then I can say that it is 6 plus 6, it is 12. Then the carry is 1, it is 1 1 1 3 plus 1, it is 4, and 28 remains as it is. Therefore this is in decimal number system. Means B1A in hexadecimal number system is equivalent to 2842 in decimal number system. Now if I observe the three conversions, the first conversion for the binary number system, the second conversion for the octal number system, and the third conversion for the hexadecimal number system, you will find that in case of binary number system, the length of the binary numbers is more compared to the length of decimal number, and it is obvious. The reason is very simple, because in binary number system there are only two basic numbers, and the resetting of the number is frequent, 0 1 again reset, 0 1 reset. Whereas in decimal number system there are 10 numbers from 0 to 9, and hence length of the binary number is always greater than length of the decimal number. In octal number system the conclusion should be same, because in octal number system there are 8 basic numbers from 0 to 7, whereas in decimal number system there are 10 numbers from 0 to 9, and therefore length of an octal number is always greater than length of the decimal number. But now instead of always, we will have to check most of the time. The reason is that for certain region, because here you will observe that there are 3 digits, here also there are 3 digits, but here it is 256 and here it is 174. That means when you reach up to 999 in decimal number system, definitely you will observe that you will override the 4th place or 3rd place, and the 4 digits are essential to express the number in octal number system for 999. But how we can check it? For that we will have to learn something about the conversion of a number from decimal number system to any other number system. Now in this method we have observed how to convert the number from binary to decimal, octal to decimal, and hexadecimal number to decimal. That means from any other number system to decimal. And now we will have to adopt the reverse technique. That means we will have to find the number from we will have to convert the number from decimal number system to any other number system. And again for that, first of all we will develop the technique with help of the conversion of number from decimal to decimal. How we can convert the number from decimal to decimal. Now here you may say that one technique is there with us. Yes, but this technique, actually this cannot be treated as a technique, but this explanation is to convert the number from any number system to decimal. I will give you one more explanation of the same. That means how I can represent 5496 in decimal to 5496 in decimal. I will give you this idea, and then you will realize that the same technique can be used to convert the number from decimal number system to any other number system. And for that, the technique is bit interesting. Now we will introduce that technique, and then we will apply that technique for conversion of decimal number to any other number system. Now we will consider any number. It is 4256 4261, which is in decimal number system, can I write this as, suppose if I divide this 4261 by 10, that means if I divide this by 10, then what will happen? The division will be 421, and then there will be remainder of 6. I will write in this way. If I divide again this 421 by 10, then the division will be 42 and the remainder will be 1. If I divide this 42 by 10 again, then the division will be 4 and the remainder will be 2. And if I divide this 4 by 10, then the division will be 0 and remainder will be 4. Correct? Now what I will have to do? I will have to write the numbers in reverse order, like it is 4216. Okay, therefore this can be treated as the number in decimal number system. Now here you will find that some error has been occur while writing the numbers. Most of the time it may happen that when we write a number or any sentence, typically for problem solving this occurs. See, here there is a error or mistake while writing from 4261. Here by mistake I have written 4216, that is 16, and therefore these numbers are not matching. Now right now what we will do? We will convert, here it is 16. Okay, but obviously because of this mistake or this error, I will have to show you that if we think a proper number, then it converts properly in decimal number system again. Therefore we will consider one more example. Suppose the number is 58623, suppose, and this is in decimal number system. Then how we can convert it into decimal number system again? I will write the number as it is. Now I should take a care that I am writing the same number, otherwise the same mistake will be repeated. If I divide this by 10, then what will happen? The division will be 5862 with a remainder of 3. Again divide this by 10, the division will be 586 with a remainder of 2. Again if I divide by 10, then the division will be 58 with a remainder of 6. Again the division will be 5 with a remainder of 8. And the division will be 0 with a remainder of 5. Once the division is 0, we will have to stop. And then we will have to write the number in reverse order, like it is 58623, which is in decimal number system. Now you may think about why there is need of conversion of decimal number into decimal number system again. Yes, it is meaningless, totally meaningless. But when we convert this, our technique of division is in decimal number system, because we are aware about the division in decimal number system. We have never used the convention like that. It is 100 divided by 10 is equal to 10. We are not aware about such type of division, though it is same for the decimal number system and binary number system too. The reason you can find, you can found or you can think about that, but this will be same for all number system with some minor corrections or minor changes. Some meaning we will have to take into account. But there is no practice that we will write this 100 in binary, we will write this 10 in binary, and we will answer that the answer will be 10 in binary. Correct? Therefore, we are using this technique to convert the decimal number into decimal by means of a division. And just like the product somewhere here, I have mentioned that the division, addition, subtraction is to be done in decimal number system, and therefore we can convert the number from decimal number system to any other number system, Now for that we will proceed with again the number in decimal number system, and we will find the number we will convert it into the binary number. Now just to keep the sequence, we will continue with the 49 itself, so that we will realize that the conversion of 49 in decimal will give you 101101 in binary. The technique is same. There is 49 with decimal number system. What we will have to do? We will have to write this number here, it is 49, and we will have to divide it by 2. See, here I have divided the number by 10, it is nothing but the base of number system in which you will have to convert that number. I wanted to convert this number into decimal number system, therefore I had used here base 10. Now I will have to convert it into binary number, therefore I will be using the denominator to be 2, that means the divider to be 2. Then what will be the situation? I will write it is 2 2s are 4, then 2 4s are 8, and with a remainder of 1. Again, if I divide the number 24 by 2, it will be 12 with a remainder of 0. If I divide it, then it will be 6 with a remainder of 0. Yes. But now it seems that something is, but we will check. Then I will write here it is 3 with a remainder of 0. Then I will write here it is 1 with a remainder of 1, and then 0 with a remainder of 1. Correct? Therefore, the technique is that we will have to write in reverse order. Therefore, it will be 1 1 0 0 0 1, and this should be in binary. It is not matching with the previous number, that is 1 0 1 1 0 1. Correct? We have measured it 49, but there will be some calculation error, and we will have to check whether this is again 49. Therefore, we will cross check here itself, and you will have to find what is the error in our previous calculation, or is there any error in this calculation. That can be treated as a homework for you. The method is correct, but there may be the error in the decimal calculation itself. It should not happen, but because of some error or some mistake, that means hurry, it may happen. Now what I will do, I will convert this into the decimal number system using previous technique, and just I will check whether it is. Therefore here I can say that this is like the confirmation, ताळा ज्याला आपण म्हणतो, 1 1 0 0 0 1. In binary I will have to convert it into decimal. Here it is 1, this value is 2, this is 4, it is 8, then it is 16, and it is 32. Therefore I will write it is 32 plus it is 16 plus it is 1, and is it same? It is 6 7 8 9, and this is 3 plus 1 49. Yes, it is correct, and therefore definitely there will be mistake in this type of calculation, and immediately I can found a mistake that here I have added 32, it is okay, 16 is to be missed, 8 is to be considered, and here it was expected to consider 4. Therefore here it is not 8, here it is 4, and therefore the answer is not 49, but it is 45. Correct? It should be 45 in decimal. Correct? There was error in previous calculation. This calculation is correct. But now once again we will check whether the 45 in decimal will give you the same result. Now the mistake leads to more practice, and therefore it is better to have the mistake at particular stage. When you try to convert a number into other, and if the reverse calculation will not give you the same number, then it will be interesting to find what is the mistake in our calculation. Now again we will convert it is 45 in decimal number system. How to convert it into binary number system? I will write here it is 45. As I will have to convert it into binary, the denominator will be 2. Then I can say that it is 2 and it is 22 with a remainder of 1. Then again divided by 2, then it will be 11 with a remainder of 2, a remainder of 0. Again if I divide 11 by 2, then it will be 5 with a remainder of 1. Again if I divide it by 2, then it will be 2 with a remainder of 1. Again if I divide it by 1, then it will be 1 with a remainder of 0. And again if I divide 1 by 2, then it will be 0 with a remainder of 1. And if I mention in reverse order, it will be 1 0 1 1 0 1, and that is in binary. Therefore these are matching, and then it is we are satisfied. Now when you suffer from such type of error or mistakes, and then when you found that mistake, and once you check that okay, this number is 45 and this is there, whereas the conversion of 1 0 1 1 0 1 is 45, then definitely you will get the excitement of the conversion of the number. And to get the excitement, as mentioned in 11th textbook, you will have to have the practice, and then when you solve something successfully, then definitely you will be excited and you may enjoy the physics and conversion of the number 2. Okay. Now as it is the technique, now this will be very simple. We will check for the octal number which we have already converted. See, we have converted the octal number 256 and we were reached to the conclusion that 256 in octal number system is 174 in decimal number system. Therefore, now we will begin with 174 in decimal and try to calculate the octal number associated with it using same technique. It is 174 in decimal number system. We will have to convert it into octal number system. I will check once whether it is 174. Yes, it is 174. Okay. And then again the technique is same. Here I will write it is 174. I will have to divide it by 8. The reason is that this should be the base of number system in which we will have to convert the decimal number system. Now though the base 8 is there, we are checking or we are considering the division in decimal number system because we are familiar with the division in decimal number system. Here I will have to write it is 8 2s are 16, then remainder is 1 among these 17, then 8 1s are 1, then the remainder is, I think it is remainder is 8 9 10 11 12 13 14, therefore remainder is 6. If I divide this 21 by 8, then 8 2s are 16 and the remainder is 5. If I divide this 2 by 8, the division will be 0, the remainder will be 2, and when I write in reverse order, it is 256, which is in octal number system. Now here you may excite, yes, it is 256 in octal number system, and while conversion of number from octal to decimal, we had reached up to the result that is 174, and therefore the reverse calculation is matching with our previous results, and hence I can say that we can convert the number from decimal number system to the any number system. Here we have converted in octal number system. Now again I will consider the same number for hexadecimal conversion to that we have used. I will check where I have converted. Yes, now I have converted this B1A from hexadecimal number system to the decimal number system, and I have found that it is 2842 in decimal number system. I know that it is a bit complicated because the remainder and etc. The table of 16 is to be used here. I don't know whether I can continue with a table of 16, but definitely I will take the help of writing the table. But we will convert this 2842 in decimal number system to hexadecimal number system. Yes, it is 1 minute again, 2842, correct. I will write it is 2842, which is in decimal number system, and we will have to convert it into hexadecimal number system. Therefore I will begin with 2842 divided by 16. Now remember that here I have written 16, not 10, which is the 16th number in hexadecimal number system, because the calculation is to be done in decimal number system, and hence I have considered it is 16, correct. Now with help of the table of 16 we will have to proceed. For that here I will write 16 1 16, 16 2 32, 16 3 48, 16 4 64, 16 5 80, 16 6 96, 16 7 12 दरसे, 16 8 28 16 8 28 असे, 16 9 8 आणि 6 44 8 चाला 1 6 आणि 44 असे, and 16 10 60 असे, 160, correct. Okay. Therefore here if I think about the 28, then I will have to write it is 16 1s are 16, then the remainder is, I will take the help of here, it is remainder is it is 1 2, then I will have to bring it is 4, then you will observe that it is this, therefore 1 2 3 4 5 6 7, it is 7, then 12 plus 12 remainder is 12, then I will have to brought it is 2, and then again we can say that it is 7 and remainder is 10, correct. Here it is remainder is 10. Okay, then divide this 177 by 16 again, 16 1s are 16, remainder is 1, again 16 1s are 16, the remainder is 1, and therefore I will have to write here it is 1. Now again I will see this was simple because 177 it is 16 1s are 16, 1 7 is there, 16 1s are 16.